today's topic will be about the stretched cluster, its requirements, and the most crucial aspects for its proper configurations, as well as some pros and cons about its implementation. And just a short intro of myself. My name is Orest, and I'm Solutions Engineer here at Starwind. So let's take a look at our today's agenda and what we are actually going to talk about today. So first, of course, we're going to talk about what a stretched cluster really is. We're also going to cover the types of stretched cluster configurations as well as their requirements. We're also going to try to understand what we should consider when implementing different stretched cluster types. And of course, in the end, we'll have a short time for the questions and answer session. So let's actually begin. And so stretched cluster is pretty much a deployment where two or more nodes are part of the same logical cluster, but are located in geographically distributed locations. In a stretched cluster, the servers act as a single system to provide high availability and load balancing despite not being located in the same facility. Basically, there is no difference in terms of functionality and operation processes between a common cluster of nodes located in a single office and a stretched cluster. The whole idea here is to make geographically distant nodes work together in a single cluster just as if they were located in the same rack. The only difference, of course, here is the distance itself. And when it comes to distance, I just want to note that from my experience, stretched clusters are built at several and maybe 10 kilometers at best. At least that's what I have dealt with. And there might be an opinion that a stretched cluster protects against the natural disasters. But we all actually know that these can take a wide area and impact both sides. So in reality, there of course can be cases when a stretched cluster might protect from natural disasters, but let's put everything in place. Typically, this can even be not the most reliable solution when we are talking about the natural disasters, as again, these can cover a huge area and both of your sides can go down. The real situation from my point of view where a stretched cluster can save your workload is a blackout in one of the sites, or for example, in one of the buildings. Of course, you can use a backup site to restore and recover your VMs, but this involves some downtime as well as data loss. Now that we pretty much know what a stretched cluster is itself, let's look at types of stretched clusters. And typically, stretched clusters are divided into two types depending on the replication occurring between them. So these are typically referred to as active-active and active-passive. So first, let's talk about the active-active replication. With such a replication type, data is constantly replicated between the servers within the cluster whenever data hits one of the nodes, meaning both sides will hold the actual data copy. Such a configuration allows load balancing the workload between the nodes, provide non-disruptive migration of the virtual machines between the servers and sites, as well as non-disruptive updates and maintenance on the nodes and sites themselves. So what are the implementation aspects and cornerstone and as well as the most important things behind this type of cluster? Well, the thing about the active-active stretched cluster is that you pretty much get the same benefits as you would get with the typical cluster. This means you can live migrate the VMs between the nodes in a cluster whenever needed and with no downtime. In case something happens to one of the sites, for example, the blackout, VMs will be failed over automatically, involving minimum downtime for services. And since each site can hold the workload, maintenance becomes much more simple and flexible, as well as installing updates or firmware can be performed on nodes on one side first and then on the nodes on the second side without having to plan the system downtime for this. And finally, the whole thing about this that you combine separate sites in a single cluster that managed locally and altogether serves your workload. Of course, you need to take into account certain things when implementing the active stretched cluster. The first and the most important aspect here is networking. The entire cluster performance and stability will depend on the network latency and bandwidth. So you typically need 5 or less millisecond latency and 10 GBE bandwidth or even higher to ensure decent performance. It is also recommended to have redundant network links between the sites in order to avoid loss of synchronization between them in case one of the links goes down. And this correspondingly translates into the high implementation costs. As you might need redundant fabrics between the sites, you need to make sure they have the low latency and have the high throughput. Additionally, a witness instance is required that can be located on the third side, or for example, in the cloud. Of course, the networking connections with the witness instance have much lower latency and bandwidth requirements. Now, let's talk about the other type of the stretched cluster. Pretty much the active-passive one. And this is based on the active-passive replication. With such a replication type, data replicates periodically. And I, however, want to note that while such a configuration is often referred to types of stretched cluster, so we typically can find that active-active and active-passive are the types of stretched cluster. From my point of view, it's not really a cluster as such. Basically, what you want from a cluster, no matter what hypervisor you are using and what is the distance, it's to have several nodes hosting workloads simultaneously, delivering high availability for the VMs, automatic failover in case one of the nodes goes down. And therefore, I personally prefer referring to an active-passive cluster as simply DR, disaster recovery. Well, nevertheless, in such a scenario, there is a primary node or several nodes that run all the virtual machines and the secondary node, or of course several nodes, that hold the copies of these VMs. In this case, if a primary node goes down, you need to bring up the VMs on the DR node, but the data they will have might not be the same. And this depends on the replication frequency you set. So what about the cornerstones and key aspects here? Well, everything is much more simple with the active-passive replication and stretched cluster of such a type. And the first question you might actually have is why we need this if we can use active-active replication scenario. And again, the answer here is the requirements. You do not need redundant network links. Of course, these can be preferable, but it's not such a strict requirement as with the active-active stretched cluster. You do not need low latency network and high throughput between the sites. And this correspondingly translates into lower implementation costs. You can even use the WAN connections between the primary and a secondary node to use the asynchronous or active-passive replication. And depending on the solution used, the network requirements can range from 100 megabits per second to 250 megabits per second. Pretty much the basic requirement you will find in most of the solutions is to simply have a stable network connection. Additionally, witness instance is not required, which makes the setup more simple and again, less costs and investments are required to configure such a cluster between distant locations. And with the active-passive replication, you can still bring up the VMs on the secondary side in case the first one goes offline. However, this involves a downtime when switching to a secondary side, and the process is typically manual, but this also depends on the solution you are using to perform the replication. Also, the largest con here is that you still lose some data depending on the replication frequency you set. Actually, the replication frequency will also depend on your dataset and throughput. So to put this simple, yes, active-passive replication has much lower network requirements. However, you need to take into account how many changes you are making to your data and what is the bandwidth between the sites. So, for example, you make the initial seeding of 10 gigabytes from the primary to the secondary site. The next change you make is 5 gigabytes. And the initial seeding, for example, takes, well, for example, 2 hours. So to replicate the changes of 5 gigabytes, it should take you, for example, 1 hour. And you have your replication frequency set to 15 minutes or 30 minutes. So in this case, it will not start the second replication, the replication of the recent changes, because it will be still performing the first changes replication. So this means while there are still low network requirements, you need to take into account the bandwidth and the changes you are doing to your data to make sure the replication frequency you set will be enough to hit that window, to hit that replication window it will require to replicate all the changes of the data. And of course, the biggest con behind the active-passive replication is that you still lose some of your data. Because with active-active replication, the workload, the data is always active on both sides. With active-passive, it's still some time needed to perform the failover, which again, in most of the solutions is a manual process, so it might take even some more time. And secondly, you still lose some data. So this always needs to be considered depending on your workload, on the services and applications you're running, if this is acceptable or not. And what about the Starwind stretched cluster implementations? So Starwind, of course, implements the stretched cluster, and it basically has two architecture options. The first one would be a typical case with the witness instance in a third location or in cloud, such as AWS or Azure. And such a stretched cluster can, of course, be built even with the 1 GB bandwidth, but 10 GB connectivity is highly recommended as it will determine the system performance, and latency should be lower than 5 milliseconds to achieve stable active-active replication. And of course, the redundancy on the network links between the site is preferable. The other option is to configure a stretched cluster even between the two nodes in geographically distant locations. However, Here, the network requirements will be more strict as there will be no witness and redundancy will be required on every level. So this is possible, but for its proper configuration, you will need redundant network cards in each node, redundant links between the sites, and redundant switches on each side to avoid a single point of failure on any level, and as a result, minimizing the risk of a split brain. Now, this is actually it for our today's webinar. So if you will have any questions, I'll gladly answer them, so you can put them in the question section. And I see the first question from David. Yes, for the Starwind stretch cluster, even 1 GBE bandwidth can be used. However, in most of the cases, it can be the network bottleneck. So we highly recommend using the 10 GBE connectivity and latency lower than 5 milliseconds. And another question from Kevin. What is the witness purpose? The purpose of the witness pretty much in any cluster and the stretched cluster deployment would be to keep the majority of votes in the cluster and ensure there won't be no split brain in case of the network interruption. The witness, so another question again from Kevin, if the witness can be hosted locally. Well, you can host a witness, for example, in one of the two locations, but this will undermine the whole concept of the stretched cluster. In case there will be the blackout, you lose the witness, and one node in the same location, the other node will also go offline. So the requirement here would be to distribute the witness either in the third separate location or, for example, in a cloud instance. And any other questions? And the next question from the Vyacheslav, which part of Starwind software acts as the witness? It's basically it can be the virtual machine depending on the hypervisor used. For example, if it's the VMware, then it's simply the virtual machine holding just the Starwind service, or it can be, in case of the Hyper-V, the instance of Starwind service on top of the bare metal Windows server. And another question, what type of witness? Disk, share, Starwind instance? So this is the Starwind instance, again, as a VM in case of the VMware hypervisor, or as the application, just as a Starwind instance in case of the Hyper-V, or it can also be, again, the cloud instance, the tiny VM in the cloud that will be just used to connect and to listen to and to determine and to make sure that there is the majority of votes in the Starwind cluster to keep the storage available and the cluster operational. And Arganis, is there a problem with the sound? Well, I hope not on my side. I hope you guys can hear me well. And the question from Kevin, can this be set up in a hyper-converged setup with just 2 hosts as a stretched cluster? Yes, in case of Starwind, this can be set up, but we would need redundancy on every network level, meaning redundant fiber connections between the sites, redundant switches, and of course redundant network cards, again to eliminate a single point of failure. And one more question, does the witness instance need a Starwind license? No, it does not need a separate Starwind license. But again, this is something that you can always confirm with our sales team, because I'm more on the technical side. And another question from Vyacheslav, mentioned that you prefer active-passive mode. Why, if some manual works required, means no critical systems? We do not, actually prefer active-passive or active-active. From the Starwind side, it does only active-active replication, hence the network requirements. For active-passive, This depends on the scenario and on the usage. Of course, in certain cases, active-passive replication is a great DR strategy. And I believe this is it. Thanks everyone for your attendance. It's always great to host webinars for you. And yeah, thank you, Vyacheslav. Nice to hear that. So thanks everyone. We highly appreciate that you're attending our webinars. Hope you like it. And of course, the record of this webinar will be available on our website. Hope this will be in a week, I guess maximum in 2 weeks. And have a great rest of the week and the weekend. And of course, stay safe and healthy. Goodbye, everyone.